So hey everyone, today Data Magic will present an e-commerce recommendation system. Me and Jenny will cover the high-level design and how data flows within the system, also how we train the model to return outcomes. Now I will hand over to Jenny for project info.
Hi everyone. First, I'll talk a little bit about our project. Our project is a data engineering project that is responsible for the data process of a grocery and ordering delivery business. And we are responsible for data integration, data asset management, the recommendation data serving, the data flow stability, data accuracy, and various data consumption requirements. Next slide, please. Here is our data lake architecture. You can see this is a large spread out architecture with a lot of components. So let's look at this architecture from the downstream to the upstream. And next slide, please. First, I'll talk a little bit about the choice of the data lake architecture. We choose to design the data lake for like first staging bucket, and then core data bucket, and then data consumption bucket. And the way we do it, why we do it is that it is cost efficient. It allows us to store large volumes of data with a significantly lower cost, and also it allows us to set like different buckets for like different stage of the data flow to be highly scalable, accommodating the growth in data volume, and also providing reliability and continuous access to the data. And also it is flexible to handle diverse workflows, data types, and for supporting data processing and analysis. And next slide, please. From here, let's start from the downstream requirements. The downstream requirements is we want a data visualization, and we sometimes can handle some ad hoc analysis requirements. And also we want to get the trained data to train the model, and we have test data to optimize the model. And with the prediction results, we want to have them in our consumption layer, and then serve the recommendation results through a AWS API gateway endpoint. And with that endpoint, we provide the data for our front end web page for our end user to use. And so like for these downstream requirements, we designed the data lake to support the whole data process for those requirements. And next slide, please. Let's look at our consumption layer. So we have dedicated tables for each requirement. So like for the visualization, we have the visualization dashboard tables. And for ad hoc analysis, we can put the analysis data set in there, because the ad hoc analysis can also would like normally be looking at a longer term of data, and that requires high throughput. So we want to have those data set put in the consumption layer that is ready for use for the ad hoc analysis. And sometimes we might need to mask data for some ad hoc analysis. So it's very so it is a good practice to have those data set ready for use put in the consumption layer, and then to use those exact data set for the ad hoc analysis. And also we have a machine learning data set, which will be test data set and training data set that is that gets updated with our data flow. And with those data sets, we train our data, and we'll be able to get new prediction results to put back into our consumption layer for the API endpoint to serve for the front-end web page. And so our consumption layer support for varied consumers, and it has we put all of the requirements, like the supporting all those requirements in this layer, and also we can enhance security and governance to the data. For example, we can mask data, or we can like control specifically of each table or like each data set to for like some specific use of some specific user. And also altogether it provides us better resource management. And next slide, please. Now let's look at our core data layer. In the core data layer, we want to provide a central repository for all the data. And we also, so in this layer, we want to find out what are the validated golden copies that we want to consider is the most accurate data to use for all the downstream use. And we keep those data in a star schema. In that way, we can, so for example, we have the visualization requirement in our consumption layer, and we want to get the data ready for use for the visualization dashboard. And with the star schema, we can easily transport the data for the dashboard use. And also it provides us simplified and unified data management in the core data layer. And also it facilitates complex data processing workflows. And next slide, please. Now let's look at the staging layer. The staging layer, we want to preserve all the data in its original form, so that whatever data, whatever data transformation ETL process that we did down the stream, we always have the original version to refer to, and we can always reason the way, be responsible for the way that we handle the data. And also the raw data is the data preserved in the raw data bucket would always be the original version of the data with all the details and no data loss in any transformation. And also it will be an immutable record of data, so it will be extra data like access control and governance method to this bucket, so that it will be immutable and we can always refer back to the raw data bucket. And also if something goes wrong down our pipeline, we can always recover and correct the pipeline from our raw data bucket. And also it provides a simplified ingestion for all our source data to be ingested or parked in the raw data bucket. And next slide, please. So for the source data, we have we have 5 files, which we consider all the historical grocery data that we have for a long period in time, and we can have all those data directly import to our raw data layer. And we also have would have a OLTP RDS relational database that is the real-time generated grocery transaction data from the grocery delivery and ordering application. And with that, for this part, we did a bit of a mock data so that we have the timestamp for each purchase. So this is a mock timestamp that we generated with Spark. And so with this generated mock data, we can simulate a batch export of those OLTP data using a Lambda function to the raw data bucket. So that's basically all about the data architecture. Now I'll hand it over to my teammate, Kevin.
Thank you. So I will talk about data flows. Our journey begins with AWS S3, so which provides a highly durable storage infrastructure capable of handling vast amount of data. So our goal is pretty clear. So to offer a centralized repository where data is collected, stored, and made accessible securely for processing. Just like Jenny has mentioned, reliability and scalability of S3 forms the backbone of our data architecture, so essential for the stages that follows. So utilizing AWS Glue crawler, so we extract raw data from S3. The crawler's goal is to scan our S3 bucket, recognize new files, and classify data formats automatically. It captures metadata from the sources and store it in the data catalog. So this metadata then informs subsequent Glue jobs. By automating this schema discovery, we simplify the essential transformation process by avoiding manual inputs. So in the transformation stage, we employ AWS Glue jobs. So the aim is to clean, normalize, and enrich raw data. So also transforming it into an analysis-ready format that sets the stage for model training. Our transformation task includes checking for duplicates, validating for null values, and also performing aggregations to enhance the data attributes necessary for effective model training. After transformation, the data is written back to S3 within the job script. We have established a Glue workflow to achieve simple orchestration. So it's comprising 2 crawlers and 2 jobs showed earlier in the architecture design graph. So it is designed to respond dynamically to new files in our source bucket. And a Lambda function is poised to trigger this workflow. So it ensures that our data is continuously and seamlessly updated. Model training is initiated once the data is transformed and stored in S3. The overarching goal is to develop a model that, upon receiving a customer ID as input, predicts and returns an array of product recommendations. Special thanks to Augusta, who is not here today, but she wrote this model training script. And this model aims to personalize customer experience by suggesting products tailored to their purchase history and preferences. Now move to demo. Also, special thanks to Kitty, who is not here today. So she developed this front-end interface. Once an external customer is on the site, they could log in with their customer ID. And once they have logged in into the site, they can then see these recommendation products based on their prior purchases. So they could choose to add the recommended product into their cart and continue from there. And that's pretty much for us. Thank you.